This diagram shows the revised architecture of the speculative Thomasoulas algorithm, where in addition to the floating point instruction queue, the floating point registers, the reservation stations for floating point adders and floating point multipliers, as well as the load units, we see on the top the reorder buffer, which receives values from the common data bus as well as the address unit, and delivers values of the results to the floating point register file, the reservation stations, as well as the store unit. In the sequel, we'll use this architecture with 3 floating point adders, 2 floating point multipliers, 3 load units, and a reorder buffer with 7 entries, in order to discuss the cycle-by-cycle execution of an example code sequence using the speculative Thomasoulas algorithm. For this example architecture and code sequence, we will assume that floating point addition takes 2 clock cycles, floating point division takes 20 clock cycles, and load operations take 3 clock cycles except the first load, which will experience a cache miss where the penalty is equal to 10 clock cycles. Moreover, we will assume that the index addresses R1 and R2 contain the value 10 each. Floating point instructions take 10 clock cycles, and floating point operations take 3 clock cycles except the first load, which will experience. Floating point operations take 10 clock cycles, and load operations take 3 clock cycles. Floating point operations take many clock cycles, which will experience.